Hi, this is Elodie for the Philosoph team, and I'm going to show you how you can easily use our tool ThorAxe. So I'm going to assume that you've already installed the tool and its dependencies. Let's say you're interested in a specific gene. So here I'm going to take the example of MAPK9, which encodes for protein kinase. And we're going to study it in 12 species ranging from human to nematode. So I have here a file with the list of the species I'm interested in. And the first thing I'm going to do is to use the transcript query script to retrieve gene annotation from the Ensembl database. So I'm going to specify the name of the gene, MAPK9, and simply the list of species with my file. So specifically, the data that are going to be retrieved are the gene tree. Also the one-to-one, so transcript query is going to look for the one-to-one orthologs of this gene in the different species, taking by default human as reference. And it's going to download as well the information associated with the transcript, so the list of transcript in all the species, and also the associated exons. For each exon, we're going to have the genomic coordinates and also the phase of the exon. And all this is going to be stored in different tables. So by default, we're going to just use the most current version of the Ensembl database. So it takes 1 or 2 minutes. Now I have a new directory that was created, which is named after the gene. So you can see that there is here information about the Ensembl download. So I have the version of Ensembl, the exon table, the sequences, the tree, and also the transcript with their quality. And now I'm just going to run ThorAxe on this. So I need to specify the input directory, the output directory. And again, I'm going to specify the species list. So ThorAxe is telling me that he found some transcripts with low support, with high support. So there are a bunch of warning messages. You should not be too worried about this. It's just basically to say what is the quality of the data that we have. So now it's done. The analysis is finished by ThorAxe. I can just go in there and see what's been created. So I have this new directory ThorAxe. What I have inside, I have a table with all the information about the S exons that were detected by ThorAxe. I also have a table with the list of paths, so a list of transcripts basically, and a table with a list of alternative splicing events that were detected. And in MSA, I'm going to have the multiple sequence alignment for the S exons. And I also have some description of the transcripts based on the S exon, so where each S exon is represented by a symbol. And this is in Philosoph directory, and it can be directly used as an input for other tool, Philosoph. So the most important, let's say, result is the evolutionary splicing graph, which is in GML format, and it's annotated. So I'm going to try to visualize this using Cytoscape. So the first thing I'm going to do is to import the file. So here I just need to navigate a bit in my folders. Okay, so I have my case study. I'm in ThorAxe, I'm here, and now I'm looking for the GML file. And I'm going to choose the hierarchical layout. So at first you may think, okay, it's a little bit fuzzy, right? So what I'm going to do is to tune a bit the representation. So I go on the style, and the first thing is to change the color of the nodes. So I'm going to use the conservation. I'm using the annotations on the graph just to show them for convenient representation of the splice graph, right? So now I'm not really seeing the names of the S-exons. It's a bit better. Now I have colors that correspond to the conservation of the S-exons, right? But I don't have their name very clear. So I'm going to change the color of the name of the nodes for white. I'm going to put this size a bit bigger, so it's much better now. I have this, so maybe I can just put that somewhere else for now. So you can see I have the start node, which is here, and then I have the stop node, which is on top. I can do a bit of tuning as well on the edges. So for the edges, I can just change here again the color. I can use, for example, the transcript fraction, which is another measure of conservation that we have. So I'm coloring the edges, and now I'm playing a bit also with the size of the edges according to this transcript fraction. So continuous mapping, it's a bit big maybe, so I may want to change that just a bit. Going down here, going a bit down here. Okay, so now it's much more clear, if we can say. So I have basically this path, main path. This is the way I should maybe see the graph. And what I can see is that there is basically one conserved alternative splicing event, which is represented here in the middle right. And this is a mutually exclusive pair of exons, 10-0 and 10-1. So now if I click on 10-0, I can here visualize its consensus sequence. So I have information about it, the conservation, all the annotations. And I also have this consensus sequence. So we can see that it's relatively small. Sections is not too long, okay. And now I can also visualize the other one. So basically they look very similar. So I can, of course, pick them together. And I can see that they look fairly similar. There is some substitution between them, but basically they're really similar. So you can pick up the differences here. So of course, when you have this, you can always go back to the MSA directory and just have a quick look at 10.0 and also the other one, which is 10.1. You can see here, so you have more than the consensus. It's really the multiple sequence alignment. So you can see that basically it's in all the species. So it's very conserved, as you can see by the color, and you have access to the sequence. Another thing that you may want to do is to visualize some, so I can also check in the AAC table what I have. So for example, the first event is exactly this one. So they are ordered based on their usage and their conservation. So again, you have the consensus sequence here, you have the genes where it's involved, and you have the canonical and alternative path. So you can see the difference is this 10.1 and 10.0. So 10.1 is in the canonical, and you can also see also in the color that 10.0 is included with less conservation, less usage. So another thing that you may want to do is to look at the path. So you have the path table and the first transcript. So these are the list. This is the list of transcripts, and the first one is the canonical transcript. So I can simply copy this code for the transcript, and I'm going to select it here. I just have to put some stars around, and now I have my canonical transcript that is highlighted on the graph. So indeed, you can see that it corresponds, 10.1 is included and 10.0 will be the alternative path. So with this, I finish here, and I hope that you've seen some possibilities with ThorAxe and that you will be encouraged to use it. Thank you very much.